Good morning, everyone. We are going to start here. Can we have signal on the presentation machine? Nice. Okay. We'll be talking about the development process of a first-person shooter, massive online multiplayer game in Unity that's for PC, Mac, and browser ready. A browser will be coming just after release. And we'll be doing this talk together with Electrotank, the providers of our networking solution. So, well, what is this project about? We'll have a live demonstration here, but I just want you to understand who is Aquiris, who is Electrotank, and what is this project about. Well, Aquiris is the developer of the bootcamp demo, the previous official Unity demo that shipped with 3.0. And from that project, we evolved all the techniques we had applied in that project, and to create a first-person shooter in Unity. And we have developed more than 30 smaller projects that enabled us to get experience to develop a big project such this one. And we have been working with Unity for more than 4 years now, and now we are heading to these bigger projects. And this FPS, it's targeted to be massive multiplayer, around 2,000 players in one server instance, not in one match room. It's 8 versus 8 match rooms, but we have up to 2,000 players in one server instance. And this is a game that takes place in the near future with a war for energy and something like that. And it's a free-to-play game. There will be item selling monetization, and that's basically what the project is about and what Aquiris is about. I'll pass the word to Mike Grundvig, who will tell you a little bit about Electrotank.
Hi, so I'm Mike Grundvig from Electrotank. I think I'm the token business guy because I've got 1 minute and that's it. So, you know, our team has been focused on high concurrency, multiplayer browser-based games for about 10 years now. You know, this specific game is being built with the Electrotank Universe platform. It's EUP. You know, we leverage ElectroServer 5 as the network layer for this game. For this game, EUP provided a extensible, flexible architecture that allowed them to use tools to support the rapid development of a lot of data-driven and data-intensive features, specifically the type of features you'd see in an MMO, and we'll get to that in a bit. Additionally, they were using ElectroServer to deliver high concurrency, low latency performance for the FPS side of the game. And again, we'll get into the architecture of that later with Jonathan Wagner. EUP also provides the dev team with an extensive set of tools that you would use to add new items and other content to the game, plus also a set of tools for managing the actual live game environment. That's actually all I've got.
Okay. So we are going to show you the live game, show a little bit of the stuff we have done. So can we change to the demo machine? There we go. It's loading. One second. Okay, it's going to work, don't worry, it's just loading. All the introduction animation that you're going to see here, it's real time. It seems like a video, but it's rendering in real time using Unity animation and all the rendering features. There you go, it's all real time, there's no video there.
Then something happened. What could have been the solution to our increasing energy demands and environmental problems evolved into a threat?
Remember, it's all real time.
A secret war had begun. comprised of the 10 most important nations in the world, the MFA established public control over the new energy source. Their intent was to make it accessible to everyone. But they faced resistance. The Smokes, a highly skilled group of soldiers formed by a private benefactor, aimed to halt their efforts. The mercenaries had a goal: to eliminate the monopoly established over the energy source. Element H2 became the most valuable energy source on Earth. Mankind, trapped by its deceptive nature, plunged into chaos again. There was no way back, but there's always a chance to make a difference.
Okay, so now we'll do some live demonstration on the gameplay and all the character customization screen and interface. One important thing to say here, all the UI you are seeing here was made with our own UI system. We don't use Unity built-in UI system, and we built our own with using OpenGL viewports and draw texture. So this is the character customization screen. You can change. The game has the concept of loadouts. You can change up to 5 loadouts, so you can change it then in real time inside the game after each respawn. You can customize your weapons, your items, your accessories. Okay, so this is basically the character customization. We have a bullet flying there. Okay, now we are going to do something very unique. I think it's the first time someone will try that. We'll try live gameplay with our team in Brazil. There you go. It's all live, guys. The other people is all in Brazil. Uma facada nele. Of course, you can expect a little bit of lag because it's almost half a second of delay from the servers in the US, and almost everyone is in Brazil, and you have Rafael here playing, so you may expect a little bit of lag. So basically, that's it. We wanted to give you this live presentation so you can actually understand what the game is about. And now we can talk about the development process and... Mostra a tela de configuração também. De configuração. Configuração. For this game, we also built our own graphics configuration system and input configuration, so we can actually change all the input keys with our own system, because the Unity system doesn't support that, all the graphics and everything. I think that's it. If you want to see more of the game, you can come to us after the presentation. And now we are going to talk about the development process itself. And from time to time, we'll be changing back to the game and showing some stuff lively inside the editor or inside the game itself. Okay, so can we change back to the presentation machine? Thank you. Acho que agora eu vou fazer a introdução. Okay, so to build this game, we had to go after networking solutions, and we already had experience with the built-in Unity solution. We developed a volleyball game, multiplayer volleyball game, but the built-in solution it's good for smaller games, and we wanted to find a more professional solution for that. So we had these options: built-in, SmartFox, Photon, and Electra Server 5. At that time, it was almost 1 year ago. And about these options we had, the one we had experience with was the built-in. It's what's the pros with the built-in solution? It's already integrated with Unity. You have easy RPC calls. You have we had previous experience with that. It's easy to control objects over the network with the sharing script properties and component properties. So it's very easy to use. What's the cons? We wanted to have a client-server topology, so the only way to do that would be have a Unity-made server, and it would run only on Windows. It's increased the server cost a little bit. Not too much, but it's still one point to consider. It was not made for thousands of players at the same time in the same server instance. And it's a very good solution for local hosted games. Like our volleyball game worked very good with this solution. But for a solution where we wanted to have more than 2,000 players in one single server instance, it was not an option. So being the built-in solution not an option, we needed to find a better solution for that. As I showed you, we had Photon, SmartFox, and Electra Server. We chose Electra Server 5 mainly because of these points. We had a great technical support from them. They even helped us to develop some part of our server-side code. They had a proven solution with previous Flash games. Even though it was different from what we were going to use, we had a lot of clients already using that solution. So we knew that they had time in the market, so they were in the business for a long time. They had also great administration tools, so it's very easy to get into the server and put your own extension there, and controls everything from the admin tools, graphical tools, multi-platform tools running over Adobe Air. And it runs under Linux. It's Java-based, and for server costs, it's perfect. So this is why we chose Electra Server. And they will be talking about some server-side development as well later in this presentation. Now I'm letting the word with Hamilton, who will be talking about the art, all the art work we have done in this game, and how we organized all this these huge environments and huge amount of assets and everything, and kept it under control.
Hey guys. Well, of course the focus of this project obviously goes to the network system and all this and all the work these guys did together to make everything work and connect and doesn't have lag and everything. But doing the project of this size, one of these challenges is to create levels that can load just one time and do not being too big to overload your video memory and something like that, and do not have too much polygons and too much draw calls. So one of the biggest challenges in this work, that it was not just big, because this project it was complex. There were so many scenes to manage, and in a project of that size, you need to take some decisions before you start doing your artwork. And another challenge was to create graphics that at the same time will be pretty, will be good looking, but they need to be lightweight. So we made some decisions to create graphics that will be lightweight to run on every machine, because one of the focus of this project, one of the focus audience is the Asia and Central America and South America markets, so we need to make sure that game will run on every machine. So the third challenge, and I think is the most challenging one, is to create not just a standalone game, but a game that is able to run on browsers. So that means we need small packages for all the artwork. And honestly, this is something we're not going talk today, probably the next year, because we didn't go through that. We are focusing right now on create a very stable and polished standalone version. So for the small packages, I think this is the challenge we are still going through. So even for creating a standalone game, you have some bottlenecks. And for this kind of game, the most important bottleneck is how to create large spaces, but not empty large spaces. You need that they have at the same time a huge space, a huge scale feeling, but also a unique artwork. So for this project, we create some rules to create our base mesh, which is basically a mesh that covers the entire level. And this mesh has some kind of different rules of modeling and texturing, different than the regular assets that we just model, unwrap UV and texture, which is the same rules everyone model and texture. But for the base mesh, there are some rules. It's maximum 50K triangles and maximum 30 objects, which means at maximum 30 different textures, and each object can have at maximum 3K triangles. So, so this object can be of any size. Doesn't matter how much we need to explore. Doesn't matter the size of the level. We can just model a base mesh of any size and just balance how expensive it will be for the performance using this few rules. So just need a few seconds to mirror my monitor and show this base mesh on Unity. Okay, here we go. So, as I said, the base mesh basically covers the entire level. So here we have a very basic modeling. Of course, it's all flat, there's no textures, but you can see that this is just a simple modeling. We have few polygons, and another function of this base mesh is to create the basic occlusion culling, because everything will be static and everything will be baked in the light map also. So this base mesh is where all the levels start. We create the level design here, we create the field balancing tests, and connected to this base mesh, we will add a lot of assets, a lot of particles and special effects, so we can create a beautiful level based on a very, very simple geometry. If I turn off that, well, that's the base mesh, just textured. It will look like that. But you can see that you don't have the complete level. It's just some empty space, just some. It's not ready for gameplay. There's a lot of things missing right here because we don't have furniture, we don't have special effects. It's just a base mesh with some good textures. And now, if we turn on the whole scene, you can see the entire composition. Oh, there we go. And all these small objects will work perfectly on the occlusion culling system because we have a lot of static walls, a lot of blockers that we will occlude these objects, and all the levels will work perfectly. So let me just switch again to the PowerPoint presentation. One second, please. I will not do that again. For some reason, I think we don't have the. Okay, finally. So another challenge is not just about modeling, because one of the bottlenecks when we need to build a level that needs to load in just one time is to create a very smart texturing. You need to have a very smart texturing technique. So it doesn't matter how is the size of the level. We created basically 50% of tileable texture for coverage, which means okay, we have a maximum of 30 textures, and we need to balance between these 30 textures, which one will be tileable and which one will be trims, which are very important and very flexible way of texturing, because you can at the same time use tileable in one direction, which is vertically or horizontally, and you can have multiple types of textures in just one file. And the third kind is the unique coverage, which is around 25%. And this is a very important texture because even in the base mesh, we don't want to have all entirely tileable, because that will be repetitive and will be boring. So a single unique texture fulfill our needs in the in a unique artwork, even for the base mesh. So basically, that's how the base meshes are structured and the way we find to build these levels in an intelligent way and keep the good looking and do not be very expensive. So the guys showed a little bit of our graphics tweaking. We think that it's very necessary in our case to create some custom parameters and do not just adjust the Unity default parameters. And we had to make sure the game will run since the GeForce 6 series, which is a very kind of old graphics card series. And all the game can save presets and auto benchmark at the first time you enter the game. He analyzes your graphics card model, your video memory, and set up the best preset for you. So this way we can make sure the game will run on pretty every machine. So, okay, now for the interesting part, guys, we'll talk about the assets pipeline, game design flow, and some of the big challenges in the network solution. Thank you.
Hi, I'm Rafael, lead programmer at Aquiris Game Studio, and I was one of the main developers of the game you were seeing. As I don't have much time, don't go deeply into any topic, and I will focus on the main challenges you face during the development of huge projects like this. First, I'll talk on how we've solved the asset pipeline issue from a tech point of view. As we have large amount of weapons, items, maps, we need a way to automate the import and build process. We also need ways to decrease memory's footprint. We started the development of this title using lots of manually setup for items, weapons, and stuff like that, and it was kind of buggy. We then started thinking about how could we solve this issue. Then we developed a directory setup that we are using to control our project. And with this directory setup in mind, we were able to create tools for automating import pipeline. We are not using a fully automated pipeline, import pipeline, because it is very buggy too. But we are using a merge of the human intelligence that will decide where, what, and when to import something, and the importer will do the dirty work, the dirty job of getting all the stuff together. Here is an example of the import system interacting with weapons. As you can see, designers and developers still have to place a lot of stuff manually. But as the system creates prefabs, materials, and scriptable objects, we made the configuration process rock solid. Another thing that deserves attention is that we are using Unity's animation importer. That's why you are seeing animations named like object add animation. This way, animation clips will get named properly. As you may know, Unity has a great feature called Asset Bundle. It's a structure that can contain portions of your project. You can put almost anything inside an asset bundle. We are using them extensively during the development of this game. We first believed that we needed to create those asset bundles from weapons, items, and maps during build time. Then we figured out that it was taking too much time to build the project. Then we decided again to make some custom tools, so we are now able to build some portions of the project, reducing the build time a lot. And here you can see the screen where we can select what will get built when you need to build something. We made it simple so anyone on the team is able to use it. One of the biggest issues we experience during the development of our FPS game is related to memory control and optimization. By using asset bundles, we have a more accurate way of knowing what is loaded, what is not loaded, and we have some methods to load and unload assets during runtime. We've built some controllers from where any code in the game can ask for assets to be loaded, unloaded, centralizing all the operations so it's easier for debug. For maps, we have a custom loader that will also unload the map and all related stuff when the player goes back to title menu. To make it easier to understand, I've compiled an overview of the system. Item controller also has an internal cache system where it keeps assets that have been loaded recently. After the assets has been used, the game lets item control acknowledge it. This way, the asset bundle can be unloaded completed from memory. So next time we need this asset again, we need to load it first. As we are making a FPS game, we have a bunch of variables that need to be balanced by our handsome game designers. At first, we thought of using XML files to let them set up weapons, for example. Using external files would increase the amount of work on code we have to do. Then we decided to use units built-in scriptable objects. These objects act like prefabs for custom classes, and they get saved when modified during play mode. So it's great for tweaking weapons during play mode, and it's easier to tweak weapons during play mode. Each weapon has a lot of configuration file, each related to one of its behaviors. Here you can see the scriptable objects related to the M16. Game designers have a bunch of parameters to set up, but also a great flexibility to make almost any kind of real-world weapon. If we were using XML files, you can imagine the amount of work for serializing and deserializing data. Levels are configured using game objects placed on each map, each scene map. After game designers finish their job, the system creates an XML file that's distributed within the servers. Here you can see, or maybe not, yeah, you can see. The generated XML file for all available maps. As I'll tell you next, the only valid map setup reside on server side. And unit is just used to make the configuration process easier. During playtime, server sends back to clients the correct configuration to be used. When playing FPS such ours, users expect the game to track their kills for each game session and allow them to level up progressively from one match to another. In our case, each user has an account which is used to control stuff not related to gameplay, like username, password, bans, and all other user-related statistics. Each account also has an avatar associated with it. We had two options available. Allow users to have more than one avatar, or giving him a single avatar and create loadouts. Loadouts are presets of avatar configuration, and we allow one user to have 5 customized loadouts. The main issue using avatars, a lot of avatars, is controlling statistics. As our game has 5 classes, and we like to keep track of them, it was better to keep them centralized in just one avatar. In order to make it simple for database design, we also converted all items in the game into loadout items. Those loadout items belong to a single avatar and will contain all information about the item they are related to, and as well player statistics on the item's usage. Here you have another view of the system and data relationship. Later on, Jonathan will explain you how EUP was able to to help us improve in our initial design and giving us tool to control all this data. Now I'll give you an overview on our network decisions. As it's a huge game, I won't be able to go deeply into it, but I'll be happy to answer all your questions during the conference. We are planning to develop a pure peer-to-peer game at the beginning. We found that it would take too much time to understand how this kind of system works. So we're falling back to the traditional client-server architecture. But then a new problem arose. We wanted to have up to 100 matches running on each server with almost 2,000 players connected. You can imagine the amount of data being transmitted and the process power needed by server machines. One of the solutions was to have almost everything computed on the clients, with the server still computing everything too, except for physics. So it has the real game state. This way, we were able to reduce the amount of data being transmitted, even if the server still needs to correct players from time to time. We are also using UDP connections to send back and forth player state updates. Those are related to player positions and animations. And for all other crucial data, we are using TCP connections. We also need a server solution capable of running on Linux to reduce costs. As you can see, we gave Electrotank folks a lot of trouble. And here you can see the final network topology we've planned. And we were able to achieve it by using Electrotank tools. Jonathan will tell you about them. Another way to reduce the amount of data being transmitted was to split users into channels and rooms. Each channel can have multiple rooms created by users where the match occurs. They can be password protected and hold all the information about a specific game. Having this kind of subdivision, we were able to optimize the data a lot. And now talking on client development, I want to give you an overview on how the game interacts with the server. We've created a transparent network layer, event-driven. We are using .NET events to send data between network layer and game layer. This way, our developers don't need to understand how the network stuff is being handled. And when you finish the development cycle, it's time to integrate the game within the existing publisher tools, like accounts, store, log systems, payment, and others. One thing to keep in mind is that you shouldn't make your game dependent on external system architectures, but must be able to communicate with them. In our case, we developed some custom tables and transactions to handle operations and communications with a publisher's system. If their system ever changes, we just need to code the interface again and not the entire game. I want to call Jonathan from Electrotank to tell you how they help us with such great tools as ElectroServer and UP. Thanks.
Hi, I'm Jonathan from Electrotank, and I just want to go over some of the solutions that we came up with for all the challenges that Raphael just described. And I'll start off with a picture, which I think looks very similar to one that you just saw, that Raphael just threw up. And basically, I want to show that, that what we did is we used one of our solutions, EUP, to basically act as the central authority or sort of the matchmaker for their game system. And then if you look over on the right side of the slide, we have these ElectroServer nodes that handle a lot of the real-time simulation. And what we've done is we've allowed communication between those nodes and the sort of central server to handle things like persistence and basically distributed the simulation across multiple servers. Some of the benefits of this type of architecture, especially for their game, is, again, I already said, distributing across multiple servers, but also the ability to have burstable capacity if you want to deploy your game to the cloud, for example. Right now, we're running on EC2. It could be running on other cloud systems, but one of the advantages there is that you can actually, with this architecture, you can spin up any number of ElectroServer nodes or match nodes to meet your capacity if you have increases and decreases in capacity during your gameplay times. And so that's very, very effective and cost efficient if you need to save money on your game. It also works well even in a data center. You can allocate new machines as you grow your game. This slide shows a little bit of a breakdown, sort of a high level of how we handle the communication between the game nodes or the match nodes and then our central server. The match nodes handle registering themselves with our central EUP server, so they can come online and go back offline at will, so you can shut them off or turn them on as needed. The EUP server handles all of the matchmaking. It assigns players to the particular matches when they log into the system. It also handles all of the persistence for all of the itemization that players have, like their loadouts, their player profiles, their loadout items, and all the items that they purchase through their publisher, which is very important that they have a central repository for all that information and that it can be transmitted to the match nodes when they join. Additionally, the match nodes can send information back to EUP for persistence, and one note I would make about that when you're thinking about doing distributed simulations is that it's okay to have co-authoritative state, but one thing you should avoid is overlapping those distinctions or overlapping those regions. You should always make sure that you have good boundaries between what servers are authoritative for what types of state. So in this case, in this example slide, the match servers are always handling the high-speed FPS simulations. They're determining things like kills and points, and they're sending that back to the central server for persistence later. The rest of my kind of discussion, I'd like to talk about something that I think Raphael's already really touched on quite a bit, and that's the job of automating your system, or I would like to call it avoiding tedious paperwork. And that's just really the idea that you can take a lot of steps to avoid problems or challenges or other types of errors when you're making a large game, especially with a large team and sometimes a distributed team. So I'd like to talk about continuous integration, automated deployments. I'd like to talk about some ideas for eliminating code and also democratizing content creation, since we're here at Unity and they're at Unite, and I think that that's one of their key goals is democratizing game creation. So continuous integration, some of you may be familiar with this, but the idea is that when you check in code, whether it be client code or server code, you check in code and you have a system that can build all your code for you. And one of the benefits of this, especially for very large games and for distributed teams, is that you can really quickly pinpoint problems where, like a really common, it works on my machine problem. Everything is working fine, I've checked in my code, but then one of my teammates, there's problems, and it's because I failed to check in a class or I've missed something. And so continuous integration can do a really good job of eliminating those types of problems, and we got them set up with continuous integration right from the start when we started doing the server-side development. Automated deployment kind of goes hand in hand with continuous integration. You can use a CI system to actually build or to drive your automated deployments. You already have a server that is handling building and packaging your products, so you can use that as a stepping stone to doing automated deployments. One thing that's very important is that it forces you to have reliable build and deploy methods up front and really start thinking about that. You want to start doing that as soon as possible when you're developing an MMO game, because the challenges only grow as your game goes live, as you have more and more data, and as you have more and more code to deploy, and you have live games, you have these live servers. It becomes critical that you have a really solid process for doing that, and it's kind of insidious. It's in development you can get away with a lot of things. You don't have to worry about merging data and things like that. But as your game goes live, it goes from a code development process to managing data. So on that topic, and please don't bring the pitchforks out against me, because I'm sure I'm in a room full of software developers, and I am too. But code is the enemy when you're dealing with a large project. The larger your code base, the more difficult it is for your developers to comprehend, and so you want to try to eliminate code or reduce it whenever possible. So that means removing code that you don't need, as well as creating code or generating code that you don't have to worry about. And I think that Raphael kind of talked about that a little bit. Instead of writing large XML files, let developers create things with tools, and let the tools mess with all the busy work. So an example of how we're solving some of those problems for their game is something that we call Protogen, which is designed to generate protocols for client-server messaging on the fly. A typical scenario when you're developing a game would be that you're dealing with an array of bytes that you serialize over the network, and the clients have to worry about this and all the little details involved with that. The servers have to worry about that. It's very tedious code, and it's no fun to write, and it's very error-prone. So what we do is we've actually created a domain-specific language. If you're familiar with something like Google Protocol buffers or Thrift, it's very similar to that, but it's very specific and game-centric that allows you to generate or to define requests, responses, and events for the server simulation and for the clients. We take that information, we run it through a processor, and then we kick out code generated for the clients and for the servers. And that includes strongly typed objects on the clients and the servers, so you don't have to guess about what the properties are that you're dealing with, as well as parsers and formatters for all the messages. There's a number of advantages to this. They may not seem obvious at the beginning, but anytime that you can come up with protocol efficiency improvements, they can be made globally across your whole game with no cost. So if you come up with a better method for, let's say, packing integers into and sending them across the network, you can easily make that change, and you don't have to go through and fix a bunch of handwritten code. This becomes very important when you're talking about an MMO game and you have possibly hundreds of different message types to deal with. Another advantage is that with using code generation is that you can actually create and model very complex data types with very little effort. Sometimes it can be very difficult or challenging to manually create like a tree or a hierarchy of objects and serialize it over the network. But if you use a sort of a protocol generation approach, it becomes easier for you to iteratively add really interesting features. For example, for their game, we have features where they can send what we call view data, and it is what's the word I'm looking for? Context sensitive, so that if I get data about my player, I get one particular view, and if someone is observing me in the game, they might get another view that has information removed from it. And those are the types of things that you can get if you don't have to basically write it all by hand. And just one other benefit is that it's very easy for you to add support for clients across languages or platforms, because it's very easy for you to generate a bunch of code to support a new language or platform. You don't have to write it all from scratch. Now, I know I just said that code was the enemy, and I guess another point I want to make is that data is the enemy too. It becomes very important for MMO games. Dealing with them is really a challenge, especially after you've launched your game. It's really a challenge to deal with all the data that all the players generate and all the data that's associated with them. one just little tidbit of information is that tool development can usually take a large amount of your, or a large percentage of your development time, sometimes up to 30 to 40%. Just a little quote I'll throw out there. I can't take credit for this one, but the tools will make or break your MMO. I actually got that from Chris Still, who's the CTO of Turbine. I was talking to him last year at Unite, and we were discussing MMO development, and that was sort of his opinion. So a lot of you might be familiar with this method of adding data or getting persistent data, throwing some data in a database using your, some command line tools, or using a big old pile of XML or something. That's really not going to be, that's not really going to empower your users to do your data entry or to spread that out across your team. You're going to be stuck with it if you're the software developer doing all that work. So instead, you want to create a rich suite of content tools that can deal with all of your data flexibly and that you don't have to spend a lot of time updating. Now, I know I just said that you might have to spend 30% of your development time working on tools, but the goal with these types of tools, and that we've achieved for them for their game, is that instead of writing a bunch of specific tools to handle data, data entry, take all your persistent data and annotate it with metadata, give that metadata to your tools, and then your general purpose data entry tools can write themselves. You don't have to spend a lot of time creating custom tools. If I go back a page here really quickly, these tools actually pull metadata from the database and from their persistent storage, and they actually develop all these fields on the fly for them. So any sorts of relationships that they create actually show up automatically in their tool suite. They don't have to recode their tools or redevelop them. And similarly, they can create new entities like their loadouts and loadout items, or basically any of the accessories that they add to their players in the game, and they all show up in the tools. They don't have to make a lot of modifications to tools. And what they can do then is what we can do is spend time making specialized operation tools that assist your game at runtime, which becomes very important once you get the game live. And my last point, that it's very unlikely that your tools are going to rise up and take over your job. So that's all I've got. Thanks.
So this is what we wanted to let you know, our experience developing this game, and we wanted to make this live presentation so you can actually see what it is about. And now if you have any questions, we have only 5 minutes. I just knew it. If there is any questions, or you can ask now, or maybe come to us after the presentation.
Over there.
And you can also go to the Electrotank booth on the sponsor area. They will be happy to answer all the questions.
We have
No, actually, the base mesh is divided into several objects depending on their texture and depending on their location. So the base mesh, the concept of the base mesh is created for the modeling to cover the entire level. But once it's modeled, the base mesh is divided based on their texture, so we can make sure that any object can have more than one single material, because that's very important. That we don't allow that any object can have more than one material. So that's how it's divided, and it's also good for the occlusion culling system to don't have huge objects, and that's how we did it.
Not at all. We are just running the logic to control kills and death and stuff like that. The physics run on clients only. We are planning on cheating tools.
Yeah, actually, we have room for cheating in this way, but would be too much to simulate all the Unity physics and everything on the server side, resimulating everything in the Java language, which is the server-side language we develop. So we have the client running the physics, but the server does a lot of validations. If the player actually could be causing this damage with this weapon at this distance, if that player was visible at that time. So there is a bunch of validations on the server.
And we also have some tools for communities to report people cheating. So I think it's the best thing to do.
So guys, we have time for one more question? One more question? I don't think I didn't get it.
It would take a lot of time to understand how peer-to-peer architecture works. We already have experience doing client-server, and we just thought that it would be better and fit better with our team. But it's a possibility too.
Yeah, it's and the peer-to-peer model. Like we wanted to have like the biggest number of players at the same time as we could, and with the peer-to-peer manage all the user-controlled rooms and how these users connect to each other and avoid net connection problems and firewall problems between the users would be harder to do, and we would not have this control in the server, like validate all the kills and deaths and how it if it like the player could actually be doing what they are doing, because they would be sending messages directly to each other. So we prefer the client-server model because of the simplicity and the more control we have on the server side. So that's it. We don't have more time. So if you have any other questions or want to talk to us, just come. Okay, thank you.